Hello students, welcome to GDC online classes. So in this session we are going to discuss regarding the drug metabolism or biotransformation of drug. So this is also one of the parameter of the pharmacokinetics. So simply the what is pharmacokinetics? So pharmacokinetics is simply what body does to the drug. So after completion of absorption, distribution, and once distribution completed, nothing but after the pharmacological action, drug should undergo inactivation in the liver. In the liver, the drug undergoes biotransformation, nothing but drug metabolism with help of number of CYP450 enzymes, that is liver metabolic enzymes. Liver metabolic enzymes. So going into detail, to convert what is biotransformation, to convert non-polar lipid soluble compounds to polar lipid insoluble compounds to avoid a reabsorption in the renal tubules. So generally, what is the purpose of metabolism? Inactivation, making the lipophilic to hydrophilic. Because of this hydrophilicity, drug is readily eliminated through the urine. Most hydrophilic drugs are less biotransformed and excreted unchanged. Examples like streptomycin, neostigmine, pancuronium. These are the drugs having hydrophilic nature. These hydrophilic drugs are unchanged, eliminated as a unchanged through the urine. So, what is the need of biotransformation? Biotransformation is required for protection of body from the toxic metabolites. So, what is the need of biotransformation? To protect the body from the toxic compounds, to reduce the drug half-life as well as toxicity. So, generally, what happens in biotransformation, drug metabolism? There are mainly two phases in the drug metabolism or biotransformation of drugs. Phase 1, phase 2. So here it is the aspirin molecule. Aspirin chemically known as acetyl salicylic acid. Aspirin is chemically known as acetyl salicylic acid. This acetyl salicylic acid converts to salicylic acid. So through phase 1, this acetyl salicylic acid converts to the salicylic acid. So let's see what changes happen here. So this is the acetate group. So this acetate group, this COCH3 is removed and there is a addition of H, nothing but addition of OH. That is phase 1 metabolic reactions known as functionalization reaction. Addition of the functional groups. Because of addition of functional groups, the drug polarity increasing. Generally drugs are lipophilic, nothing but lipophilic in nature, lipid soluble. But in the phase 1, initially one of the drug converts to another form of the drug with a polar nature, means increasing hydrophilicity. And in the phase 2, if we observe, in this OH, the H will remove and in place of hydrogen, conjugate substance, a large molecular substance will bind here, will undergoes conjugation. So conjugates are highly water soluble molecules, and generally these phase 1 reactions are known as functionalization reaction, phase 2 reactions known as conjugation reaction. These conjugating molecules form a complex with the drug molecule that become more hydrophilic. That hydrophilic will readily eliminate from the body. So here some of the exceptions in phase 2. What is the sum of the exceptions? Generally, if a drug molecule passes the phase 2, most of the drugs are become inactive, they eliminate through the urine. But some of the examples like minoxidil converts to minoxidil sulfate, not sulfide, minoxidil sulfate, which is an antihypertensive drug, and the morphine converts to morphine 6-glucuronide. So generally after phase 2 the drug molecules are inactive. Some of the exceptions like minoxidil converts to minoxidil sulfate, a antihypertensive drug as a vasodilator, and morphine converts to morphine 6-glucuronide, which is a potent analgesic compared to the morphine. Next, what is the result of biotransformation? What happens if a drug undergoes biotransformation? Active drug and its metabolite converts to inactive metabolite. The active drug metabolite converts to inactive drug metabolite. So example, the drugs like ibuprofen, paracetamol, chloramphenicol examples. Next, conversion of active drug to more active drug. For example, phenacetin to acetaminophen or paracetamol, morphine to morphine 6-glucuronide, digitoxin to digoxin. So conversion of active form of drug to the more active form of the drug, more active form of the drug. Next, conversion of inactive drug to active or enhanced activity, that is prodrug. Conversion of prodrugs to the active form. For example, levodopa is a prodrug, converts to carbidopa. Levodopa converts to dopa, and prednisone to prednisolone, enalapril to the enalaprillad. So prodrugs are converts to the active drugs. Example, levodopa to dopamine, prednisone to prednisolone, enalapril to the enalaprillad. So next, no toxic or less toxic drug to the toxic metabolite. So sometime no toxic or less toxic drug converts to more toxic drugs. That is, conversion of paracetamol to N-acetyl-para-benzoquinone. Conversion of paracetamol to N-acetyl-para-benzoquinone. So here simply the drug in the form of active form, that is drug or poison, undergoes biotransformation. So here I am telling active drug may converts to more active drug. This active drug may converts to more potent form. This active drug may converts to less potent form. This active drug may converts to toxic form, and this inactive drug may converts to inactive form also. So these are the different functions of the biotransformation. Active drug converts to inactive, active drug converts to more active, inactive prodrugs are converts to active drug, no toxic or less toxic drugs are converts to toxic drugs. That is, conversion of paracetamol to its toxic metabolite N-acetyl-para-benzoquinone. Next, as I mentioned earlier, there are two phases of the metabolic reactions in the body. One is phase 1 or non-synthetic, metabolite may be active or inactive. Next, phase 2 or synthetic, metabolites are inactive. That is, morphine 6-glucuronide is the exception. So phase 1 also known as non-synthetic or functionalization reaction. Phase 2 are also known as synthetic reactions or non-functionalization reactions. So if a drug molecule complete phase 1, the drug may be active or inactive. But once the drug molecule contain nothing but completed phase 2 drug metabolism, drug is 100% inactive. Some of the exceptions like minoxidil to minoxidil sulfate and morphine to morphine 6-glucuronide. And so there are, as I mentioned earlier, phase 1 reactions also known as functionalization reaction. So there are oxidation, reduction, hydrolysis, cyclization, decyclization are comes under the phase 1 reaction, and glucuronidation, acetylation, sulfation, methylation, glutathione conjugation, amino acid conjugation, thiosulfate conjugation, these are comes under the phase 2 metabolism. Nothing but phase 2 metabolisms are known as conjugation reactions. Phase 2 metabolic reactions are known as conjugation reactions. Next, first we will go with the oxidation, phase 1 oxidation. Regarding phase 1 oxidation, most important drug metabolized reaction, that is simply addition of oxygen or negative charged radical or removal of hydrogen or positive charged radical. So simply this is the basic thing, oxidation. So addition of a negative charged species or removal of a positive charged species. So there are various oxidation reactions like oxygenation, hydroxylation of carbon, nitrogen or sulfur atoms, or nitrogen or 𝘂-dealkylation. Examples like barbiturates, phenothiazines, paracetamol as well as steroids undergoes oxidation reactions. And the enzymes involved in the drug metabolism are CYP450 enzymes. And here only 3 isoenzyme families are there, especially CYP1, CYP2, CYP3. Only 3 isoenzymes are there: CYP1, CYP2, CYP3. Next, so here CYP3A4 or 5 carry out biotransformation of largest number, that is 30 to 50% of drugs. So here many number of metabolic enzymes are liver CYP, cytochrome P450 enzymes are there. Among 50 to 60% drugs can metabolize by using the CYP3A4 enzyme, CYP cytochrome P450 enzymes. 3 means family, and A means genus, and 4 means gene number. So here CYP3A4 is the one of the metabolic or liver CYP enzyme responsible for around 50 to 60% drugs metabolism. And in addition to liver, these isoforms expressed in intestine responsible for the first pass metabolism, and also present in the some of the enzymes also present in the kidney. So especially here there is in addition to liver the isoforms, these enzymes also present in the intestine. So these enzymes present in the intestine may responsible for the first pass metabolism of a drug. So what is first pass metabolism? If you taking any drug through the oral route, before reaching the systemic circulation, the drug may be inactive in intestine as well as liver, known as first pass metabolism. Next, so before that we discussed microsomal enzyme oxidation. Now it is a non-microsomal enzyme oxidation. Some drugs are oxidized by non-microsomal enzyme, that is mitochondrial and cytoplasmic. Example like alcohol, adrenaline, mercaptopurine. So alcohol metabolized by alcohol dehydrogenase, adrenaline metabolized by monoamino oxidase and COMT, catechol O-methyl transferase, and mercaptopurine metabolized by the xanthine oxidase. Next, after oxidation, next is the reduction. The reaction is converged of oxidation and involves CYP450 enzymes working in the opposite direction. So reduction is opposite of the oxidation. Examples like chloramphenicol, levodopa, halothane, warfarin undergoes this reduction. And here levodopa is the first drug of choice for treatment of Parkinsonism. In presence of dopa decarboxylase, it converts into dopamine. So peripheral conversion of levodopa to dopamine can be inhibited by dopa decarboxylase inhibitor carbidopa. But in the CNS, we should promote conversion of levodopa to dopamine. That dopamine binds to the dopamine receptors in the CNS, nothing but central nervous system. Next, hydrolysis. So hydrolysis is nothing but cleavage of drug molecule by taking up of a molecule of water. So generally the drug molecule in presence of water can undergo hydrolysis. For example, acetylcholine converts to choline as well as acetic acid. Similarly, amides and polypeptides are hydrolyzed by amidases and peptidases. So amides, drug containing amides hydrolyzed by amidases, and substance with polypeptide in nature metabolized by the peptidases. So generally hydrolysis takes place in the liver, intestine, plasma. Examples like choline esters, procaine, lidocaine, pethidine, and oxytocin undergoes this hydrolysis phase 1 metabolic reactions. So simply ester with help of water in presence of esterase enzyme converts to acid as well as alcohol. Next, cyclization. It is formation of a ring structure from a straight chain compound. Example is proguanyl. Cyclization is a formation of ring structure from a straight chain compound. Example proguanyl. Next, decyclization. It is opening up of the ring structure of a cyclic molecule. Example phenytoin as well as barbiturates. Cyclization means the non-cyclic compound converts to cyclic compound. Decyclization, cyclic compounds converts to the non-cyclic compounds. So these are the general phase 1 reactions happening in the body with drug metabolism or drug biotransformation. Next, the important thing is phase 2 metabolism. Regarding the phase 2 metabolism, here phase 2 metabolic reactions are also known as conjugation reactions. Conjugation of drug or its phase 1 metabolite with an endogenous substrate, and polar highly polar and highly ionized organic acid to excrete in urine or bile. So what is happening here? Phase 2 reactions are conjugation reaction. In this, the drug molecule is known as hexagon, which is taken from outside of the body, and endogon is a conjugate present inside of the body. Hexagon forming complex with endogon. Endogon is a conjugative substance polar in nature that bind with the non-polar hexagon. Both forms a complex with a covalent bond, and which leads to increase in the polarity of a drug molecule. And especially phase 2 conjugations are energy dependent. They are saturated if sufficient energy is not there. Next, glucuronide conjugation. Glucuronidation conjugation is the most important synthetic reaction. Compounds with the hydroxyl or carboxylic acid group are easily conjugated with glucuronic acid. So that is derived from the glucose. So here uridine diphosphate glucuronic acid is a cofactor for this glucuronidation, and uridine phosphate glucuronyl transferase enzyme is the enzyme catalyze the glucuronide conjugation reaction. So examples like exogenous compounds as well as endogenous compounds undergo this glucuronidation, nothing but phase 2 conjugation. Examples like chloramphenicol, aspirin, morphine, metronidazole, bilirubin, thyroxine. So generally, glucuronidation is a major conjugation reaction in the phase 2, and most of the large molecular weight compounds or drugs undergoes conjugation reaction, that is glucuronidation. Drug glucuronides excreted in bile because of their large molecular weight can be hydrolyzed in the gut by bacteria producing beta glucuronidase. Liberated drug is reabsorbed and undergoes the same fate, that is enterohepatic recirculation. So generally what is happening here, hexagon endogon forming a complex through glucuronidation. The glucuronide metabolites are passing to the bile. So during this process, sometimes some of the enzymes releasing from the bacteria in the intestine, they break down complex between hexagon and endogon. Then there is a separation of hexagon and endogon. So when this will happen, the endogon conjugated substance will be separated and hexagon non-conjugated or lipophilic substance will be separated. Because of this lipophilic substance again recirculated into the body through the enterohepatic recirculation, enterointestine, hepatic, liver. So hexagon endogon. So the drug molecule which is ready to metabolize it will form complex with conjugate. So that conjugate because of covalent bond. So sometimes this conjugate passing to the intestine, there is a chance of breakdown by the enzymes. So during this hexagon endogon will be separated. The hexagon will be again lipophilic, and because of lipophilicity it is again reabsorbed into the circulation through intestine and liver, so known as enterohepatic recirculation. Drugs like chloramphenicol, drugs like phenolphthalein, drugs like oral contraceptives having this enterohepatic recirculation property, and because of this enterohepatic recirculation the drug half-life is increasing. Next, continuation, acetylation. Compounds having amino or hydrogen residues are conjugate with help of acetyl coenzyme A. So here it is the acetylation. So acetylation is one of the phase 2 metabolism. So the drugs undergoes this reaction acetylation. So compounds having amino or hydrogen residues. Examples like sulfonamides, isoniazid. Acetyl-CoenzymeA is the cofactor, and acetyl transferases are the enzymes involved in the catalyzation of acetylation as a phase 2 reaction. So especially genetic polymorphism leads to slow as well as fast acetylators. So in some of the human beings, acetylation reaction is fast. In some of the human beings, acetylation reaction is slow. This is because of genetic polymorphism. Next, sulfate conjugation. Sulfate conjugation. This is also one of the phase 2 reaction. So sulfate conjugation is one of the phase 2 metabolic reaction. So especially the phenolic compounds and steroids are sulfated by the sulfokinases and also nothing but sulfotransferases. The cofactor is phosphoadenosine phosphosulfate known as PAPS. So PAPS, that is phosphoadenosine phosphosulfate, is the enzyme responsible for the catalysis of the sulfation conjugation, that is one of the phase 2 metabolic reactions in the liver. So sulfokinases or sulfotransferases are the enzymes, and the sulfate conjugation is for drugs containing phenolic compounds as well as steroids like testosterone, estrogen, progesterone undergoes the sulfate conjugation as their metabolic inactivation. Examples like chloramphenicol, a antibiotic for protein synthesis inhibitor, and as well as ethylene as well as sex steroids. Next, methylation. Next is the methylation. So regarding methylation, this is also one of the biotransformation under phase 2 conjugation reaction, but generally it is not regarded as a true detoxification because it is involved in the synthesis of substance like ethylene as well as histamine. So methylation is not a true detoxification or true biotransformation. It is not a true drug metabolism, or it is not a true detoxification reaction because it involves in the synthesis of a substance like ethylene as well as histamine. Generally, biotransformation is the responsible for the inactivation. So the amines and phenols can be methylated. Examples like methionine and cysteine acts as a methyl donors. So methylation, so nothing but methyl transferase. SAM, S-adenosyl methionine is a cofactor. Amino acid conjugation. So amino acids undergo conjugation by using. So here the conjugation reaction involves with help of amino acids, and examples like nicotinic acid, 𝘂𝙧ic acid, salicylic acid undergoes amino acid conjugation. Next, thiosulfate conjugation. So this is thiosulfate conjugation involves detoxification of cyanide to the thiocyanide. So cyanide is a toxic molecule, lipophilic. The toxic lipophilic converts to non-toxic hydrophilic with help of thiosulfate conjugation. The enzyme is rhodanase, RHODANESE. RHODANESE is the enzyme. RHODANESE is the enzyme responsible for make the conversion of toxic form of cyanide to the detoxification of the thiosulfate. So thiosulfate is water soluble, which is readily eliminated through the thiocyanate, not thiosulfate, thiocyanate. Thiocyanate is a water soluble and eliminated through the urine. Next, ribonucleoside or nucleotide synthesis. Activation of many purine and pyrimidine antimetabolites used in the cancer chemotherapy. So ribonucleoside or nucleotide synthesis is a conjugation reaction. This is involved in activation of purine and pyrimidine as well as antimetabolites used in the cancer chemotherapy. Next, the important thing is deconjugation. The important thing is the deconjugation. So deconjugation is observed only in glucuronidation, one of the phase 2 major metabolic reaction. In phase 2, the exogon, that is drug molecule, and endogon, a conjugated substance present in the body, forms a complex, and complex from liver through bile duct enter into the intestine. So from the liver through bile duct enter into the intestine. The intestine consists of an enzyme beta glucuronidase which produced by the microorganisms. This beta glucuronidase cleaves the covalent bond between hexagon as well as endogon. So endogon is a conjugating substance which provides polarity to the drug molecule. So as a result, the hexagon lipophilic drug molecule gain its lipophilic nature and enters into portal circulation known as enterohepatic circulation. As a result, due to the entry of drug back may causes toxicity in the body. Examples like morphine, vecuronium, rifampin like drugs undergoes this enterohepatic circulation and increases their half-life of drugs. So here this is the enzyme. What is the enzyme here? That is beta glucuronidase. That beta glucuronidase breaking the bond between hexagon and endogon leads to the endogon polar moiety separated and hexagon moiety separated. This hexagon again enter into the systemic circulation through intestine and liver known as enterohepatic recycling. So if this beta glucuronidase enzyme was inhibited, then there is no separation of hexagon and endogon. This leads to elimination of this complex through the urine to the outside of the body or bile. So calcium D-glucuronate. So calcium D-glucuronate or calcium D-glucuronic acid found in fruits and vegetables inhibit the beta glucuronidase enzyme. So continuation. So the deconjugation makes a reabsorption or reactivation of drug and increase the half-life as well as toxicity of drug. And next, the important thing regarding this metabolism or biotransformation of drugs is enzyme induction as well as enzyme inhibition. So there are number of pharmaceutical drugs we are taking into the body. Among that, some of the pharmaceutical drugs in the liver increase in the liver metabolic enzyme, that is enzyme inducers. Some of the pharmaceutical drugs are decreasing the enzyme levels known as CYP enzyme inhibitors. So the enzyme induction also known as induction of metabolism. So by increasing the enzymes, they increase the metabolism, drug metabolism. Enzyme inhibition known as inhibition of metabolism. They inhibit the liver enzymes and decrease the drug metabolism. So enzyme induction is increased production of liver enzymes or synthesis of CYP enzymes due to drugs or other exogenous substances, that is smoking. So here enzyme induction means it is a process of increased enzyme levels, increase in production or synthesis of liver enzymes, metabolic enzymes. So especially some of the substances like smoking may increase the liver enzymes. Next, enzyme inhibition. Enzyme inhibition is decreased production or synthesis of CYP enzymes due to drugs or toxic substance. Here, due to some of the drugs decreasing the synthesis or inhibiting the liver enzymes. Enzyme induction, nothing but inducing the enzymes, responsible for metabolism. Enzyme induction is a slow process, takes 1 to 3 weeks, but enzyme inhibition is a rapid process. So construction it will take time, but destruction is a rapid, like enzyme inhibition. So increase in drug metabolism which leads to decreased efficacy, duration of action, half-life of drug. So enzyme induction, enzyme induces increase in the liver enzymes. So when liver enzymes are increases, that liver enzymes increase the metabolism of drug. If metabolism of drug increased, that leads to decreased efficacy, decreased pharmacological activity, decreased duration of action of a drug, decreased half-life of drugs, because here the drugs are metabolizing fast. And regarding enzyme inhibition, decrease in drug metabolism leads to increased efficacy, increased duration of action, increased half-life may leads to toxicity, because here enzymes are inhibiting. If enzymes are not producing or not there is a no metabolism of drug. If drugs are not metabolizing, the half-life of drug increases as well as toxicity also increases. So because of enzyme induction, alteration in physiological state due to induction of steroid metabolism. So some of the drugs increasing the liver metabolic enzymes. If that metabolic enzymes metabolize the steroids in the body, that leads to alteration in the physiological state of the body. Continuous enzyme inhibition leads to toxicity of drugs. So if there is a rapid inhibition of the metabolic enzymes, that leads to toxicity of drug, that is therapeutic failure. So here some of the list of the example I mentioned here. This is very important regarding your competitive orientation. For example, scrap ZP is a trick to remember the drugs increasing liver CYP enzymes, and these examples are known as CYP enzyme inducers, metabolic enzyme inducers like sulfonylureas, carbamazepine antiepileptic drug, rifampin antitubercular, alcohol, phenytoin antiepileptic, griseofulvin antifungal, phenobarbital sedative hypnotic. Next, the trick 𝙂𝙋𝙎𝙎𝙬𝙄. This is a trick for remembering enzyme inhibitors, that is CYP enzyme inhibitor. So that is sodium valproic acid antiepileptic drug, isoniazid antitubercular drug, cimetidine H2 receptor blocker for treatment of ulcer, ketoconazole a antifungal drug, fluconazole antifungal drug, alcohol binge drinking, chloramphenicol antibiotic, erythromycin macrolide antibiotic, sulfonamides antibacterial compounds, ciprofloxacin a antibiotic synthetic, omeprazole H plus potassium ATPase enzyme inhibitor as a antacid, and metronidazole anti-amoebic drug. So this is the examples under the enzyme inducers, means increase the liver enzyme levels and increase the metabolism of drugs, and here enzyme inhibitors decrease the metabolic enzymes and decrease the metabolism of drugs. So this is simply about what is drug metabolism or biotransformation. So what is drug metabolism or biotransformation? So what is the definition? What is the importance of biotransformation? What are the basic points regarding biotransformation? What are the reactions involved in biotransformation, along with the examples, and importance of deconjugation, and after that the very importance regarding enzyme induction and enzyme inhibition. So this is regarding the class of drug nothing but biotransformation of drugs or drug metabolism. So the purpose of drug metabolism, make a drug molecule to more polar, which is readily eliminated through the urine. The purpose of drug metabolism, make a drug molecule inactive and decreases the toxicity of a drug molecule. Toxicity of the drug molecule. So this is the session on the drug metabolism or biotransformation of drugs. So this is the session, and we will connect with the next session with another topic.